everyone. Today we're going to learn how to fit a line to data, also known as the line of best fit. Let's take a look at the first scenario. Describe the correlation of the data graphed in this scatter plot. Take a look at this. See all the little points here? Hours of studying, test scores. As the hours of studying goes up, the test scores go up also. So it keeps going up, up, up. And so this is called a positive correlation. Okay, if it has a positive slope, it has a positive correlation. All right, let's take a look at another picture. Okay, the table shows the lengths in centimeters of swimming speeds in centimeters per second of 6 fish. So what we could do is we could use X and Y, X, Y, X, Y, X, Y, X, Y, and make a little scatter plot out of this. So we graph it, and notice what happens here. We plot these points. This is the length of the fish, and this is how fast it goes. So as the length goes up, we'll notice like an appearance of the numbers going up. So if we treat the data as ordered pairs, we're going to go ahead and we plot everything, and it shows a positive correlation. You can see it going up, 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 up. All right. Now let's make a scatter plot, or actually I'm going to have you make a scatter plot. Here's like we got 1, 2, 1, 3, 2, 4. So look at all these little points. I graphed them. Describe the correlation of the data. Pause your video, write down your answer for what is the correlation of this data. All right, let's see how you did. The scatter plot shows a positive correlation. All right, let's take a look at example 3 here. The table shows the number of active red-cockaded, I can't pronounce that, I'm so sorry, woodpecker clusters in a part of the DeSoto National Forest in Mississippi. Write an equation that models the number of active clusters as a function of the number of years. All right, so this would be year 0, since 1990, so this would be year 2, and then 22, 3, 24, 4, 27, 5, 27, 6, 34, and so on. We go and plot them onto a graph, and voila, this is what it looks like. Now, yes, it's a positive correlation. By the way, we didn't show you any examples of negative correlation. Just so you're aware, if you had a bunch of dots going like this, that would be a downward slope, so that would be a negative correlation, just so you're aware of that. Let's go ahead and go back to the problem that we're looking at, though. All these are the points that we have, and we plot them, and you can tell it's a positive correlation because it goes uphill. Now let's take a look. We actually can make an equation of a line. We pick a point, and we notice we draw our line trying to go through the center of all these. We have a point right here that's 220, so we could write down 2, 20, and we have a point over here that's really close to it. So let's go ahead and write down that point. And so what we could do is we would write down 220 and then 842. Now, if you're wondering where I got the 842, here's 8, go up, look, 42, okay? So, we get these slopes by subtracting the y's over the x's, like we always have, 11/3. Now, to write the equation, we can use either one of these points, and then we use this as our slope. So, we type them in, we use 20 equals 11/3 times 2 plus b. We get 38/3 for our b value. Now, we could write this equation, y equals 11/3 x, using the slope, and then the 38/3 for your b-intercept. So, the number of y of active woodpecker clusters can be modeled by the function y equals 11/3 x plus 38/3, where x is the number of years since 1990. All right, let's have you guys give it a try. Use the data in the table to write an equation that models y as a function of x. So you're going to use your graph paper. You're going to have the y's go all the way up to 14 and the x's go up to 8 when you make your table, or I'm sorry, your graph. All right, I should see a point at 1, 3, 2, 5, 3, 8, 4, 9, 5, 11, 6, 12, and 8, 14. Pause your video and describe the correlation. Now that you've described the correlation, you would see that as the x values go up, so do the y values, so I know it has a positive correlation. Now, if we actually were to graph this, we could figure out that the slope was about 1.6. If you did not get 1.6, it's not that big a deal. You could get a 1.4, a 1.7, something close to 1.6. And then that would affect this number here, so something close to 2.3. All righty. Well, that's it for tonight. You're just learning about taking scatter plots and deciding what the correlation is. And I will see you guys tomorrow.